In the name of Allah, hello students, welcome to our class today. I hope you are doing great as usual. As I said to you students yesterday, today we will start our lesson from sockets and slots. Students, the microprocessors are attached to the motherboard of the computer. There are two general types of mounting used to connect the processor onto the motherboard: sockets and slots. Some processors are available in only one mounting type. Others, such as the Intel Celeruns, are available with both types of mounting, which type is used as largely a matter of preference on the part of the processor manufacturer. The two types look very different, but functionally their differences are small. As you see, students, the socket is shown in the figure, and this socket is the room of the processor on the motherboard. Let's go ahead, students. Okay, socket types. Students, here are usually 11 of the most commonly used socket types. The first one, students, sockets starts from 0 to 7. As many students, we have socket 0, socket 1, socket 2, socket 3, socket 4, socket 5, and socket 6, and socket 7. And after socket 7, we have the super 7 sockets, and after that we have a socket that called socket 8, and the last type of the socket is socket 317. Then their characteristic is different student from each other, and their characteristic like usage of quantity of the electricity, and also their pins are different from each other. Okay, students, let's go ahead. Okay, slot types. There are four types of slot mounting used to attach the microprocessors to the computer. The first one, students, is slot 1 or SC242 connector. The next one is slot 2 or SC330 connector. The next one is slot A, and the last one is slot M. These four types of slots are different, and their characteristic is also different. Okay, students, let's go ahead. Okay, the evolution of the PC microprocessor. Other manufacturers such as AMD, the VIA, Cyrix, and other make excellent processors, but Intel is by far the leading manufacturer of PC microprocessors or CPU. Intel has consistently set the standard by which all processors are measured. Okay, students, the first one or the first type of microprocessor is 8086 and 8088. In the 1978, Intel introduced the 8086 microprocessor, which had a clock speed of 4.77 MHz. The clock speed of a processor is the speed at which the CPU operates. Clock speeds are rated in megahertz or million of electronic cycle per second. A computer rated at 5 megahertz has 5 million processing cycles per second. The more cycles per second a computer supports, the more instructions it can execute. Remember that the most instructions, because they include many processing steps, including memory transferring, ALU or arithmetic logic unit operations, and etc., required more than a single CPU cycle to complete. Okay, students, let's go ahead. Okay, students, the next one is the Intel 80286. Computer manufacturers largely skip it over the next Intel microprocessor generations. The 80,186 to adopt the Intel 80,286. The Intel 80,286 is shown in the figure, and you are using in your computer screen, and maybe in the your telephone screen. IBM chose the 80,286 for its next PC release. The PC-80, the 286 processor, as it was commonly known, was released in nearly 1982 with a 6 megahertz clock speed. 134,000 transistors and nearly 3 times the power of the 8086 with 0.9 million instructions per second. The 286 was able to address 16 MB of memory with addresses buses expanded to the 24 bits. Its data bus was also backward compatible to the I think 8086 original 16 bits. Later 286 versions had clock speeds of 10 megahertz and 12 megahertz. Okay, students, let's go ahead. Okay, students, here is the Intel 80,386 and 80,386DX and 80,386SX. Intel released the 16 megahertz 80,386, commonly called the 386, in 1985. The 386 microprocessor was a full 32 bits processor packaged in a 132 pin PGA package. The 386 had 275,000 transistors and had the clock speed to support over than 5 million instructions per second, while it had a 32-bit mode, which meant it was able to move data in bytes, 6 bits. Two features provided by the 386 were improved virtual memory capabilities that allowed a large amount of memory to be temporarily stored on the hard disk, and instruction pipelining, a processor that preloads and pre-evaluates complex instructions, which results in faster processing speed. The Intel 386 had versions which clock speeds ranging from 16 MHz to 33 MHz. However, other manufacturers, specifically AMD and Cyrix, had competing processor versions with speed up to 40 MHz. Okay, students, let's go ahead. The next one is the 386DX. Students, the first of the 386 processors introduced by Intel was the 386DX. The 386 was a true 32-bit processor and included 32-bit internal registers, 32-bit internal data bus, and a 32-bit external data bus. It was built with a new technology called VLSI, or Very Large Scale Integration, with 275,000 transistors. The 386 used less power than its processors, including the 8086, because it was constructed of CMOS materials, a way of manufacturing a transistor that reduces the amount of power required when ideally. The 386DX could addresses up to 4 gigabytes of system memory but it's built in virtual memory management. System allowed the virtual memory management enable software accesses a virtual memory store of the equivalent of 64 terabytes or TB of memory. A terabyte is a trillion bytes of memory. As we had discussed about the terabyte or the memory units in the computer fundamental book in the first semester. Okay, students, let's go ahead. The next one, students, is the 386SX. Intel also released a lower cost version of the 386 processor called the 386SX. The primary difference between the 386 SX and the 386DX was that the SX model had only a 16-bit external data bus and a 24-bit addresses bus, which made it backward compatible to the 286 processor. The 386SX was released to fill a market need, which was a lower priced processor with the power of the 386DX at the cost of the 286. Okay, students, let's go ahead. The next one is, students, the 386SL. Intel released the 386SL, which was a 20 megahertz processor in the 1990. The SL versions was similar to the 386SX, but it was specifically designed for portable computers, featuring improved power management functions. Okay, students, let's go ahead. The next one is the Intel 80486 DX2 and DX4. Processors did not break the 1 million transistor barrier until Intel released the 25 megahertz 486DX microprocessor in early 1989. The processor had over 1.2 million transistors and generated 20 million instructions per second. The processor also introduced a number of innovations, including the inclusion of processor cache L1 or level 1 cache on the processor chip. The introduction of burst mode memory access and for the first time and integrated math processors before the 486DX. If a user wishes to speed up the math function on a PC, separate math coprocessor had be installed. The 486 was packaged in a 168-pin ceramic pen grade assembly or CPGA package that required a processor mounted fan to cool it. Okay, students, let's go ahead. The next one is AMD 5X86. The next model of the 486 was released in the 1992. But students, the AMD 5X86 Intel did not have much competitions until Advanced Micro Devices or AMD released its 75 megahertz 5x86 microprocessor. The AMD 5x86 processor were compatible with the 486 motherboards, but had similar power to the early Pentium processors. Okay, students, let's go ahead. Okay, the next one is Cyrix 5X86. The Cyrix 5X86, also known as the M1 SE, was intended to compete with the Intel 486, with which it was socket compatible, like the AMD 5X86. The Cyrix processor was able to compete with early Pentium processors. Okay, students, let's go ahead. The next one is the Pentium. Students, the Pentium name is familiar with you, I know, but what do you think about the Pentium? Pentium computer, Pentium 1, Pentium 2, Pentium 3, many years ago, and the people were using from that. But what do you think about the Pentium computer, or the Pentium? The Pentium name isn't the Pentium. In common, students, we can say that the Pentium name is the microprocessor. Students all thought it was known in its early development as the 80,586. By 1992. Intel had discovered that model numbers could not be copied. So instead of the number, they used a trademark named Pentium for their next processor. This processor shown in the figure, and you are seeing that in your computer screen, maybe in your telephone screen, included many new features, including separate 80-bit caches for data and instructions, and a very fast FPU. The Pentium kept the 32-bit addresses bus of the 486, but added a 64-bit data bus. It also included superscalar architecture, which is a processor technology that allows more than one instructions to be executed in a single clock cycle. The clock speed of the Pentium processor ranged from the 60 megahertz to 200 megahertz. Okay, students, let's go ahead. The next one is MMX technology. The next version of the Pentium processor was the Pentium MMX, which had a clock speed from 166 MHz to 233 MHz. This version of the Pentium processor added MMX, or multimedia extensions technology, to the Pentium, along with some improved internal clock speed. MMX technology is a set of instructions that use the matrix math, or another meaning for MMX, to support graphic compressions and decompressions algorithms, such as the GPEG, GIF, and MPEG. And 3D graphics rendering. MMX allows the FPU to act on several pieces of data simultaneously through a process called SIMD, or a single instructions multiple data. Okay, students, let's go ahead. The next one is the Cyrix 6X86 processor. Cyrix, which is now VIA, Cyrix produced a family of Pentium clone processors that were designed as the 6X86P series. The P value and the model name was a performance rating indicator. The 6X86P200 indicated that the Cyrix processor with the model number had a performance equivalent of a Pentium 200 MHz processor. Cyrix produced models ranging from its SXX86 P120 to the SXX86 P200. The SXX86P series had overheating problem as well as some impossibility issues, which prompted Cyrix to produce a low power, a low temperature version than SXX86 said. Okay, students, the next one is the other Pentium clones. Two other manufacturers produced processors to compete with the Pentium. The AMD K5 processor with a version of 75, I think, 75 megahertz to 166 megahertz. Unfortunately, suffered from its own complexity, which affected its processing speed. The integrated device technology, or IDE, Center when chips C6 included MMX extensions, has a large L1 cache and is less expensive than the 200 megahertz Pentium MMX. Okay, students, let's go ahead. That was our lesson, students. Today, please pay attention to your homework. The first question of your homework: what called the first processor, or what was the name of first processor? The next one, when introduced the first processor, and also students research about the characteristic of the first processor. Okay, students, it was our lesson today. Tomorrow we will have discuss about. We will start our lesson from Intel Pentium Pro. Thanks for your watching. Have a good time. Good luck.